Good morning, everyone. Thanks for signing on. My name is Yandre Terreblanche. I'm the Technical Support Manager at SigmaTEK Systems. And today we're going to be talking about the 10 important functions you need for sheet metal manufacturing automation. Before we get started, I want to tell you a little bit about our company. We've been in the industry for 20 years. Our headquarters is in Cincinnati, Ohio. We have about 200 employees worldwide. The red dots on the map here are our corporate offices, and the blue ones are our value-added resellers. Okay, let's go ahead and take a look at the 10 things we're going to be talking about today. CAD integration, quoting, work order tracking, color offload, making sure we have a press break solution, auto nest, nesting for NC, remnant tracking and material handling, some sort of automation, and then an MRP ERP solution. Okay, the first important function we're going to talk about today is dealing with engineering information properly. In other words, dealing with CAD. So you do not want to put a workflow burden on the engineering department to push out data in a special format like a DXF. What you want is a pull system. This means you read the native file and you process it. Let's take a look at an example. Here we have a part in SolidWorks. It's a sheet metal part. It has a couple of bends. I'm using SolidWorks just as an example. You should be able to integrate with a variety of CAD packages, including Inventor, SolidWorks, CATIA, whichever CAD package your engineering department had. So let's go in SigmaNest. We'll go ahead and hit Import SolidWorks Part. We'll select our part and we'll press Open. So we can see here's our part, and basically what happens here is it's being unfolded according to the bend allowances and K factors specified in the host CAD system. So here we have our part in SigmaNest. You can see it recognizes the material, the thicknesses automatically, and a lot of the part properties. We'll enter the number to nest here, since this part is not coming from an assembly. And then there we have our part. So we'll go ahead and hit Auto Process. And basically what we're doing here is we're just putting this part down onto a sheet. After this process is completed, we can take a look at the tool path that's applied to it, and we can see the machine here in the background as well. And then we can run through a quick simulation just to make sure it's running exactly the way we want it to. As it's running through the simulation, you can also take a look at the exact code that's going to be posted out to the machine. But again, dealing with one part at a time is not really that realistic. Engineering information normally exists in assembly form. So let's take a look at a more true-to-life example. Let's say we're a job shop. Here you can see there's an assembly. It's made up of some sheet metal parts and some parts that are not going to be manufactured on our profile cutting machines. And let's say we have to manufacture the parts for this. So we say Import SolidWorks. We grab our assembly. And here you can see all the parts that are in the assembly are automatically recognized. The material is recognized. And in this case, the quantity is recognized as well based on how many times they appear in the assembly. Here is the actual part tree from the host CAD system. With its respective configurations. And again, these configurations can be set up in a variety of ways. We've applied one filter here, which is a keyword filter in the file name for hex. We do not want to include those hex bolts into SigmaNest. After we've applied all our filters, we hit OK. And the parts come into SigmaNest as SigmaNest parts. And here you can see some of them are on the left side. There's also some properties as well as a preview of the part itself. And again, material properties, including thickness, material type, quantity, is automatically recognized by the nesting software. All right, so here is our assembly. We'll go ahead and process that. And the software is going to run through a quick nest, and we can look at the tool path, we can simulate it, and if you're happy with this result, you can render it out. So this leads into our second function that we have for today, which is quoting, because before we can take this order, we need to know how much it's going to cost. Okay, here's an example layout that we've already made in SigmaNest, and you can see the toolpath is already applied. If we take a look at the report for this slide, we can see all the parts ordered with their associated costs and cutting time on any particular machine. This is a scientific result based on a costing engine that accurately reflects machine rates, machine operating costs, the cost of material, the amount of material consumed, the exact weights of the parts, etc. For example, you cannot use a cut length or just a top-end speed for the parts because oftentimes the machine has to slow down in the real world, like a laser or a water jet that has corner ramping or plasma cutting bolt hole quality holes. Otherwise, you'll underestimate how long that's going to take. You don't want to take on a project that's going to cost more than you're getting unknowingly. After this, you can move on to print quotes or reports for your shop floor. And these should be clear and easily customizable like they are in SigmaNest. And here's an example report of our sample layout, and you can see it shows a small preview of the part and some details such as the cutting time and the net weight, and as well as the nested cost for each part. The next step upon acceptance of this quote is to take the order. In SigmaNest, you have a button that basically means take the order, and that brings us to topic number 3 for today. Topic 3 is work order tracking. Being able to track work orders helps your company stay organized, it helps reduce the number of errors, it reduces the paper use in storage, and provides simplified task lists for the programmers or operators. So let's take a look in SigmaNest. In SigmaNest, there is a button called Work Orders that basically shows you the list of current tasks for your programmers. So here you can quickly see from the list what stage a particular work order is in, whether it's overdue, still in progress, or already completed. This tool also allows you to arrange your work to make it easier for you to interpret, for example by customer. You could also do it by due date, or you can do it by due date as a subgroup of customer. In this case, you can easily see which of your customers you have work orders for and when they need to be completed by. So this is a very powerful way of managing multiple orders from multiple customers through a common work center like a laser or a plasma machine. Okay, let's go ahead and import some of our work orders that we have not yet started. This brings in all of the parts in those work orders into SigmaNest, and we are going to nest them all together. Oftentimes, you don't have the luxury of mixing orders, and that's for the convenience of the shop floor. And in that case, once we hit nest, your nest is going to look something like this. Here we have parts colored by work order and separated on the sheet by work order. If we take a look at the report for this nest, we can see that it's at 33.7%. Okay, now let's mix work orders for the sake of efficiency. We'll modify this task not to discriminate between different work orders. Alright, upon renest, you can see we're nesting multiple work orders on the same sheet regardless of their location on the sheet and regardless of which work order they are in. This gives the nesting engine more flexibility for placing parts. Let's go ahead and take a look at the report for this layout. 30.2%. That's a 3.5% gain simply by applying the features of the tools at your disposal. Now, to eliminate confusion for the production floor, since all the parts from different orders are mixed together, I want to introduce the next function called Color Offload. Color Offload is a shop floor module that shows on a touchscreen basis exactly what's going on. Once a program gets posted, it shows up in Color Offload and the operator can quickly and easily see which program to run next, as well as which parts are in that program and what work orders those parts are associated with. Color offload also gives the operator the ability to provide feedback to the programmer and the management office. Let's take a look at color offload. Here's the program we've posted from SigmaNest, and the operator can, for example, click on a part, reject it, and he could provide a reason for why it was rejected, and even enter a comment more accurately describing what happened. And once this part is rejected, it's automatically updated in SigmaNest. The programmer will see that this part needs to be recut, and the work order will display as incomplete. The next topic I want to talk about today is SigmaBEND. Having a bending software is important because the problem is we cannot always make it the way engineering modeled it. So we may not have the necessary tooling for the design method, or the press brake may not be able to physically reach into certain areas of a part as originally designed. So let's go ahead and take a look at an example. So here we have a part in SolidWorks. Again, SolidWorks, I'm just using it as an example. So this is a sheet metal part that ultimately needs to be formed into this shape. So I've imported the SolidWorks part into SigmaBEND so that it can be unfolded, and the flat pattern can be brought up and placed with the selected machine. At this point, you can also apply manual bends with specified tooling and configuration settings, or you can accomplish this all automatically by selecting Automatic Bend Sequence. So this will search, and as SigmaBEND is searching for all possible bend solutions for any particular part, it will display and it will allow you to select the most desired one. This part only had one solution, and as you can see, we're running through the simulation here, and it's showing you the necessary tooling and bend sequence to complete the part. The last step is to create a bend report for the press brake operator with instructions and bending details, and this should include the bend sequence, some operation details like the force used, tool load, etc. It should show all the necessary tooling as well as machine setup instructions. And finally, these reports should be customizable to allow you to show each bend sequence in a customized orientation for clarity. The next function on our list is automatic nesting. It is important to obtain and apply the most efficient automatic nesting engine that you can find. It is also important that this nesting engine allows the flexibility of user intervention as needed. So we've seen a couple examples of this already, but let's take a look at some other nesting situations. Here we have an example workspace. We have a couple parts loaded in already. They may look familiar from before. They were one of our work orders. So with these parts loaded into SigmaNest, whether they came in from a CAD package as an assembly or as individual parts, whether they came from a DWG or a DXF, or these parts could have been created inside SigmaNest itself. So we'll go ahead and run through a quick auto nest. We'll grab the parts, nest them together. So this is basically the software thinking through endless possible part combinations in order to yield you with the most efficient nest. Now let's go ahead and look at another example. Let's say our machine had 2 torches. So we'll change the number of heads to 2, and we'll hit OK. Once we re-nest, now you can see the parts are being nested with a master and a slave identically for both torches. And actually a manual intervention at this point will automatically update properly for the second torch, so you don't have to calculate exact spacing and so forth for parts. You can simply and easily just move one part at a time. Let's take this example to the next level. So let's say we have 4 torches and we're cutting across possibly multiple sheets of material, not necessarily just one, on a large bed machine. So we'll turn on multi-sheet nesting. We'll modify the task just to add a few more parts here to give us more to work with, and then we'll go ahead and re-nest. As you can see now, it's nesting for 4 torches across multiple sheets here. And again, manual user intervention will make it simple to make modifications to this nest. This can even be pushed further into an endless number of sheets or the number of sheets that you can fit on your specific machine, or even nest on a coil feed system for an undetermined amount of material. So again, to recap, you want a software that will give you the most for your material, as well as making the programming, especially small, simple modifications to a job, a painless task. But finally, you want to be able to nest for your specific machines. And that brings us to our next topic. Nesting for cutting. This is a big one. A shop that wants to be efficient and effective should have one software which can drive all of your cutting machines. This could include an array of different processes, including laser, plasma, oxyfuel, water jet, routers, even punch presses, and multi-process combination machines. So now let's take a look in SigmaNest how to program some of these different types of machines, but from the same interface. As you can see here, we have parts nested that could be cut on a pure plasma, on a punch plasma or punch laser combo, or on a pure punching machine. So the first one we're going to take a look at is a combination punch profile cutting machine. So after creating this nest, we need to apply a combined tool path, and this is done simply with going into AutoNC, verify that we have the correct machine. In our example, we're going to use a Whitney, and applying auto punching where relevant. Once we hit OK, this will bring up the tool sort dialog and allow us to group by tool usage. And after that, we can simulate our results. Again, now it's running through the simulation. We can see the hits are of the same tool as we group them together, and you can see that it's doing all of the punching of the internals before it starts profile cutting the externals. Alright, so that's one example. The next example we'll look at is a pure punch trump. So we're going to be using the same parts, but now we're going to be programming them for a punch press. We'll edit the parameters, we'll select our new machine, and once we renest here, the software now automatically takes into account new clamp positions, the size and clearance specification, and nests appropriately. It also automatically pre-tools the parts being nested with tools that are in the tool library. So during this process, it takes into account your turret size, the number of stations it has, and in order to nest the appropriate parts on any given layout, to make sure that we do not nest a combination of parts that will require too many different types of unique tools to finish the punching completely. And that is, again, if you want SigmaNest to decide which tool should go in the turret. You could also alternatively set up pre-configured base turrets to use at all times, or a combination of the two. So again, here we have the tool sort dialog with our tooling applied. The tooling was automatically selected by SigmaNest. And again, we're going to sort this to be punching generally towards the clamps as to maintain as much sheet integrity as possible. Okay, once the tool sorting is completed, we can run through a simulation. And we can see it's got some small destruct area. Again, it's trying to group tool usage together to minimize tool changes, and simulating its way through the rest of this layout. Again, this is very beneficial for fabricators needing training only for one software instead of several different kinds, even as extreme as a different software package for each type of machine. In SigmaNest, you're able to program for many different kinds of machines with a variety of processes, all from the same interface. Our next topic is remnant material handling. A couple things I think that's important for a full-featured manufacturing software is material remnant creation as well as tracking. So the software should be able to automatically recognize which sheets or plates in your inventory will optimize material usage and which sheets to use next. Let's take a look at an example in SigmaNest. As you can see here, we already have a few parts loaded in, and we're going to go ahead and create a nest from these parts. Okay, as you can see, the second layout there used only part of the sheet. So this large open portion of material we'd like to save for future use. So this we can do in our toolpath. So once we click Auto NC, we will specify our crop sheet settings. In this case, I'm going to use crop step 2. It'll just grab me that little bit of extra material at the cost of an uneven sheet edge. But this doesn't look too bad, so I'll go with it. Now, for illustrative purposes, I did not filter the remnants by minimum required area before being selected, which would normally be the easiest way. But here you can see the portion, this portion will be primarily useless. So we can use it with the internal to external area ratio slider, or we can simply deselect it from the checkbox. The top material is the remnant that we want. So once we acknowledge it, we can hit OK. Now let's go ahead and post this program. This will send it out to the floor, at which point it will come up in color offload. It will be run by the operator. And then we will go to our program update and tell SigmaNest that this program has been run on the shop floor and the remnant material has been created. Once these two layouts are updated, the inventory is automatically updated, the work orders are automatically updated, and those can now be used for future nests. So the next example I want to take a look at is another way to handle remnant material is to not necessarily do a crop line. So in this case, we'll just grab this one part. We'll go ahead and open our library and grab the remnant that we just created, which is this one. And we'll load it into the workspace. And basically, I'm just going to nest this part in the top left corner. I'm not going to do a crop line. I'm not going to do any other parts. And this is just an example of where I want to keep this sheet of material just with that one part cut out, but have it automatically remember for making future nests not to nest parts in that area. And as you can see, there's the remnant with the part cut out, and it's ready for the next nest. So just to recap on remnant functionality, the software should have a best sheet option to help select the appropriate remnants or sheets for the appropriate tasks, not just at random. The next function I want to talk about today is SimTrans. This is primarily a shop automation software. As shops and processes become more sophisticated, automating these processes can greatly help increase a facility's production potential. So I'm just going to mention a couple things and a couple functions here, which include integrating with your existing ERP systems, automatically updating your inventory, automatically creating work orders for your programmers, and then creating feedback communication from the shop floor and the management and production software. So SimTrans is basically an automated transaction tool to help speed up some of the more tedious daily tasks. And I think that having automation capabilities helps create a leaner manufacturing operation. Our final topic for today is SigmaMRP. SigmaMRP is a full-featured manufacturing resource planning program that contains a number of modules that can be utilized. These range from tracking your work from the very beginning, where you're costing out a preliminary quote through the ordering process, sending the work to the shop floor for production, planning other shop works outside of strictly CNC cutting. This can include purchasing raw materials, as well as other shop items, and then ultimately invoicing your work and sending the invoicing records to your accounting department so you can get paid. This MRP suite is very versatile in that you can select any combination of modules to fit your needs, even if that means only the contacts module, for example, and that would basically serve as a glorified phone book. But utilizing all of the features will take your facility to the next level of integration. And the way I like to illustrate this is that this software takes you from getting a business card at a trade show all the way to getting a check in your hand for your work. It allows you to manage your manufacturing business practices from first contact, when you first meet your customer. You can market, you can set up appointments to get back with them. You can design a marketing plan for everyone who gave you business cards, push that information through your sales pipeline, and allow you to take requests for quotes and turn it into an order. SigmaMRP is also a perfect match with SigmaNest, which gives you detailed information about the materials consumed in the profile cutting processes and machine time. Being fabricators, that's the heart of your business. But Sigma MRP also allows you to extend that costing information to every other aspect of your business, from bending, powder coating, welding, painting, even all the way to packing and shipping. So let's take a look at Sigma MRP. Sigma MRP also follows the Microsoft Office motif of ribbon bar with group functionality in each tab, similar to SigmaNest and SigmaBEND. And as you can see, there are categories of functions with the 9 Sigma MRP modules across the top. So let's take a look at contacts, the first tab, and this is where you keep all of your prospects, the customers and suppliers, and these sort and filter easily. For example, I put an S and the E in, and we're basically left with this guy. I want to focus on the admin screen, and this is where you set up all of your default values and settings for how you want to use MRP. And a very important part is called resource data, and this is where you group your processes into assembly, finishing, machining, profile cutting, etc. So let's take a look at welding, for example. We can edit the resource, we can add all our costs per minute for the operation, or we can add a fixed cost, such as every time we use the MIG welder, $20. This is all under your control. You can also set up an operation so that if you always want this process to go to a specific subcontractor, then that would be set up here. The reason I'm spending a little extra time here is because now you can offer this service. If you add a new resource, you can put this in a quote. You'll know you're always getting X number of dollars for this operation. And this is a way you can fine-tune your costs to make sure that you get the most accurate cost available for any particular job across multiple processes. And with MRP integration with SigmaNest, if a customer gives you a DXF or a SolidWorks model or a different CAD model, you can determine their true shape or nested cost immediately. You can get the cutting time from the machine immediately. You can even build those SigmaNest parts that may include operations outside of SigmaNest, again, such as grinding or drilling. Then you make all of those parts into an assembly, and you can export your cutting machine tasks for processing in SigmaNest. SigmaNest then, at the completion of its work, updates the information for the raw materials that were used, which is immediately available inside of SigmaNest, as we saw earlier, but now also in your MRP system immediately, so you can quickly see what's going on. And then automatically raw material can be ordered for stock that's either depleted or getting low from the dedicated suppliers that you may have set up in the admin screen. So to recap, what we talked about today was integration with our engineering department on a native level, quoting the work after bringing it into SigmaNest to realize the cost, creating a work order from the quote, being able to track that, sending that out to the machine, giving the operator the ability to quickly and easily see what's going on with color offload, and feedback to the engineering and management departments. We talked about a press brake solution, SigmaBEND. We talked about auto nesting sheet metal parts, and then nesting for your specific machines, including a variety of machines all from the same interface. We talked about remnant tracking and being able to create remnants, and the software being able to help you select which remnant material to use next. We talked about automation capabilities. As shops become more sophisticated, having these automation capabilities to stay competitive. And then finally, an MRP or ERP solution for your manufacturing facility. Thanks, everybody. If you have any questions, please feel free to email us at sales@sigmanest.com or visit our website, www.sigmanest.com. Also, feel free to check out our YouTube channel for case studies as well as other customer success stories. Thank you.